Myself Tahira Mazumdar. I'm from IT department, Ajay Kumar Garg Engineering College. And today I'll be talking on the topic basic structural modeling, which comes under the subject object-oriented system design. To start with, the topics which I'll be talking about is I'll be starting with class modeling, then I'll talk about objects and class concepts. I'll talk about link and association, then I'll talk about factors relating to association, talking about multiplicity, generalization, inheritance, and I'll take some sample examples of class models. To start with, we know that there are three kinds of models, the main important models in object-oriented modeling: class model, state model, and interaction model. Class model, it is used for modeling the objects in the system and their relationship. State model, it is used to model the states various objects take in the system, and we can say it models the life history of an object, and it shows how the object system behave internally. Now, when it comes to interaction model, it is used for showing the interaction among the objects in the system. It shows basically the behavior of systems in terms of how the objects interact with each other. Now, out of these three models, in today's lecture, we'll be focusing on class model and further concepts related to class modeling. Now, to start with, first let us discuss what exactly is a class. To start, a class basically is a collection of objects that share common properties, attributes, behaviors, and semantics in general. So, this collection of objects, they have the same data structure. When you're talking about data structure, we are talking about the attributes, the variables that goes into the making of the object, and they also have the same behavior. By behavior, we are talking about the functions, the codes related to it, and the operations in the solution space. So, collection of objects sharing common properties, we call it as class. And when you're talking about common properties, we're talking about the same kind of data structure and the same kind of behavior. Now, so basically classes, it focuses on grouping of common objects into classes. So, another important aspect of class, we call it, we say instantiation. Now, what is instantiation? So, we can say class basically categorizes a collection of objects with same common properties, and instantiation is the art of creating an instance. And here, what is instance? Instance, by instance, we refer to as objects. Now, if we look at this particular figure, and in this figure, we are seeing that they are three different objects. This is a car, this is another car, this is car 1, this is car 2, this is car 3. They have common properties in the sense that they are having 4 wheels, they are used for driving, and they are having window panes and so on. So, we can say these are three classes of the same category of class called car. These are three objects. These are three objects of what class? Car. Now, when we are talking about these objects, as I told you, as we are defining the very thing, we are saying they have the common characteristics or common properties related to the data structure and the behavior. Now, here we are talking about, for this particular example, when you're talking about this example car, what are the attributes? The attributes, when you're talking about car, in this particular example, the attributes are, we can say, the model of the car. What is the model of the car? The location of the car, the number of wheels. We can also add some more attributes as per our requirement, like we can say what is the color of the car, what is the make of the car, what is the price of the car. So, these are properties related to the objects which fall under the same category of class, that is car. So, we call these properties as attributes. Now, by operations, we mean what are the functionalities, or what are the work that this particular objects of this class can perform. So, by car, what are the functionalities, or what are the operations that the car objects or the car class can perform, or rather we can say objects of this car can perform. What are the operations? The operations are these car objects. They can start, they can accelerate, they can give brake, they can we can hear music on the car, and so on. So these are some of the operations. So all of these objects, we have got three distinct cars. So these are, we can say, these are instances of what? Of class car, fine. And these are the attributes and the operations. So by car, by class, we are basically referring to collections of objects that share the common properties. So these are the collections of objects having the common properties like model, location, number of wheels, having operations like starting and accelerating. Now, what is a class diagram? Next topic, what is a class diagram? It gives us a graphical notation for modeling classes and their relationships, and thereby describing possible objects. So a class diagram basically is a diagram via which we can model we can graphically view the class, how exactly a class is, what are the attributes that makes a class, what are the operations that goes into the making of the class. So an object diagram, basically it is something like this. Now, okay, before that, let me just talk about what exactly object diagram is. When you're talking about class diagram, it indicates, it's a diagram that graphically views a class. Object diagram, it is a diagram that graphically views an object. And what is an object? An object is an instance of a class. So we'll go to the object diagram in the subsequent slides. For the time being, let us focus on class diagram. This is how a class diagram looks like. Now, a class diagram will have three important components. The first component is the class name, which is always written on the top. The next component is attribute, and then followed by operations. So what is the class name? Basically, in the class, we have different kinds of classes. Obviously, we have different collections of objects with sharing common properties. Like here we had the example of car. We can have the example of transport. We can have the example of animals. We can have the example of human beings, and so on. So this we call that particular, we give a name to the class, and the name is written on the topmost half. So so when you are representing a class, it is shown via a rectangle, which is including the name, the attribute, and the operations. So if you look at the class name, the first one, the class name is the only required, it is a mandatory tag in the graphical representation of a class, and it always appears in the topmost compartment. We write it on top. I'll take some example later on as we move further. Like for example, when we are talking about that example of car, so in this case, our class name will be car. And then we'll come to attributes and properties later on. So the previous example, the name of the class was car, fine. Next is attribute, the second aspect. Now, we are taking an example. In this is an example of a class diagram where the name of the class is person. So when you're talking about person, as I told you, in the first box, we have the class name. In the second box, we have the attribute. And in the third box, we have the operations. So when you're talking about a class person, what are the attributes or the properties that are unique for a class of that particular type? In this example, it is person. So the attributes, when you're talking about a class person, are, or the attributes, when you're saying what are attributes, that means the characteristics through which we can uniquely identify one object from another object of the same class. So one is the name. Like normally people, different person have got different names. The address, the birth date, the SSN number, and so on. So these are the properties, and these are the data types of this particular properties. So this is the attribute when you are talking about a class person. So to define technically, we can say an attribute is basically a named property of a class that describes the objects that are being modeled. So through the attributes, we basically describe the class that we are talking about right now, and attributes always appears in the second compartment. Now the operations is the third field, which comes in the third in the bottommost segment. So it describes the operation. What does it do? It describes the class behavior and appears in the third compartment or in the bottommost box. Now when you're talking about a class person, here what is the class name? The class name is person. So with respect to class name, we have talked about attributes. Fine, attributes are name, address, birth date, SSN. Now with respect to class person, we are talking about operations, like what do objects of class person do, or what are the kind of operations this particular class objects of this class perform. So person object class objects can perform operations like eating, that is what people do, sleeping, working, playing, and so on. So these are activities or operations performed, and we put it in the third compartment. So this is how a class diagram looks like. We have, it's something like this. We have the first compartment, the second compartment, and the third compartment. In the first compartment, we have the account name. In the second compartment, what is, for example, we are talking about, this is an example of a class related to bank account of different customers. Bank account of different customers. So when you're talking about bank account of different customers, so different customers, let us say customer C1, customer C2, customer C3 will have different bank account number. Let us say this will be having account number something like this. This will be having account number, let us say, and this will be having some other account number, something like this. So you have different account numbers. So these are objects, and all these account numbers are having similar characteristics. So we group them together and we say that they fall under a certain class, and that class name is account name. Now under account name, we have the properties. Different customers, what are the distinct properties of the objects of that particular class? So different customers have different customer name, they have different account balance. We can also add some more attributes if required. In this example, we are just taking 2 attributes. You can have other attributes like account number, the balance, the date of creation of the account, and so on. Now next is the operations. When you're talking about operations that is performed on bank account class, the operations are like adding of money to the account, adding of fund to the account, withdrawing or making a transfer. These are some of the operations that is performed. So this is how a class diagram looks like. You have a rectangular box having 3 compartments. In the first compartment, we have the class name. In the second compartment, we have the attributes listing. And in the third compartment, we have the operations that are performed on the objects of that class, or rather what the objects of this class can perform. Now moving further, when you're drawing this class diagram through UML notations, what are the conventions that is normally used when you're going for class diagram? Now, so we have, when you're talking about diagrams, we can have class diagrams and we can also have object diagrams, as I told in the previous slide. So you can have class diagram, we can have object diagrams. So as I told you in the previous slide, what are objects? Objects are instances of the class. So you have multiple objects of the same type grouped together, we call them as a class. Now in this particular example, we have class diagram and we have object diagram. And what are the conventions that are used? For symbol for classes and objects, for both of them, it is a rectangular box. Objects basically are modeled using boxes with object names followed by a colon. You have the object name followed by a colon followed by the class name, and both of them are underlined. So this is specific of an object diagram. Whenever you're having an object diagram, you need to have the object name followed by a colon and then the class name underlined. This is specific. This is how an object diagram looks like, and we also can model it like this without giving the specific object name, but underlining it, indicating that it is also an object diagram. Next is when it comes to using, we normally put them, we align them in the center and we capitalize the first letter. When it comes to class diagram, we just write the class name. But when it comes to object diagram, we write the object name as well as the class diagram. These are some of the conventions used for UML notations. Now, what are values and attributes? Now, value basically is a piece of data. Fine, but what does it do basically? Value, it is used to describe an attribute, which is a named property of a class. Values describe an attribute. Like for example, if we are taking attribute name, birthday, and weight, these are attributes. Fine, like attributes of what? These are attributes of which class? As per this example, these are attributes of class person. Fine. Now the attributes takes values. Name attribute takes value Joe Smith. birthday is 21st October 83 and weight is 64 kg. So these are the values which the attributes takes. So we put it like this. Now, how do you model them in UML notations? Now, when you're modeling them, this is the class diagram, where, as I told, you have the attribute names followed by the data type of the attribute. When you're having the object diagram, what we do is that we have the object name followed by the object, we have the unique object name followed by the class name. And when you're saying the attributes, we write the name of the attribute followed by an equal to and followed by the default value of the attribute for that particular object. Let us say for the object Joe Smith, what is name? The name is Joe Smith. What is birthday? The birthday is 21st October 1983. Similarly for Mary Sharp. Fine. So we can, in a class diagram or an object diagram, the basic requirement is you need to have at least one box, minimum one box, which will name the class diagram or the object diagram. In addition to that, optionally, you can also include box for including the attribute and subsequently for including the operations that can be performed on the class diagram or the object diagram. Now, when you're talking about operations and methods, we normally these two names are taken simultaneously or parallelly, but they indicate the same thing, but there is a slight difference between these two terms. The difference is that when you're talking about operation, it is basically a function or a procedure that may be applied to objects in a class. But when you're talking about method, it means the same thing, but method represents the implementation of an operation for a class. That means when you're talking from implementation point of view, we normally use the term method, and when you're talking from the conceptual point of view, we normally use the term operation, though they indicate the same thing. Example, when you're talking about a class company, for example, when you're talking about a class company, so company will have its own attributes and properties. It will have attributes and methods. Sorry, the attributes can be when you're talking about attribute, in this particular example here, hire, fire, pay, dividend, these are basically operations. Fine. For let us say we are talking about class window, a window class. What are the operations that can be performed? We have open, close, hide, redisplay, and so on. These are the operations when you're talking about class window. Now, the point to be noted is that the same operations may apply to different classes, and such operations are called polymorphic operations. And later on, when you are going to the implementation implementation view, this polymorphic operation leads to polymorphism, which we'll learn in detail when you go for object-oriented programming languages like Java, C++, and so on. Now, when you are taught, so this is a summarization of the UML notation. Let us say in the third compartment, how do you write it? You have the name, class name, the attribute name, and the UML conventions for the operations which are listed in the last compartment. Here they are. Normally we write it in regular front. It is left aligned, and we normally use lowercase letters. This is an example of a class diagram named person, and this is an example of a class diagram named file. Now the next topic which we'll be talking about is links and association. Fine. Now, what are links? This is a very important topic when you're talking about UML diagrams related to class or other class diagrams. What are links and what are association? They are means for establishing the relationship among objects and classes. So links are used to indicate the relationship that different objects or different classes have. Links and association are used for that particular purpose. What is a link? A link is a physical or a conceptual connection among the objects. So when you want to model the relationship between objects, we use the term link. We graphically use do that through links. And when we want to model relationship between group of links, or rather between classes, we call it as an association. So association basically is a description of group of links. And when do you have group of links? When you are taking the relationship between classes. Why so? Why classes? Because a class is basically collection of objects. So collection of objects, so when you're seeing the relationship between objects, so it will automatically indicate relationship which are indicated by group of links. Example, like in this example, we are talking about a specific object, Joe Smith, which is person working for a company, the name of which is Simplex, and the link name, the relationship is works. Here, instead of object, we are having class, the person. Instead of a simplex company, we are generalizing it by the name company. And this is what here, this is no more, we'll not call it link, we'll call it as association, and this is link. So link is used to indicate relationship between objects, and association is used to indicate relationship between classes. So if you look at this example, this is a diagram which shows class diagram and object diagram. Now class, this is here you have class diagram where we are giving it in a more generic view. We have class person related to class company, and these are some things which may not be very clear right now. I'll be talking it up again in the next slides. And here, for the same class diagram, these are the object diagram where we take objects of the same class. Like here we're taking 1, 2, 3, 4, 5 objects of class person. So of class person, this is the object diagram. So object diagram, if you remember, I said you write the object name followed by the class name, and it needs to be underlined. So we have 5 objects: John, Mary, Sue, Alice, Jeff, and these are the attribute value names. And these 5 objects having links with company, like person, John is working for company GE, Mary is working for company GE, for example, and Jeff is, let us say Jeff is, Alice is working for company IBM, and in this example, Jeff is not working in any company. So here, this we can say, now this is a relationship that shows, this is a link, this is a line that shows a relationship between classes. So we'll call this as association, and this lines show relationship between objects, so we'll call them as links. So this is a distinct difference between link and association. So association connects related classes, and while links connect objects. Now the next topic which we'll talk about is multiplicity. What is multiplicity? Multiplicity basically defines the number of objects that are associated with an instance of the class. Like for example, here if you look at it, here the UML diagram, if you look, explicitly lists multiplicity at the end of the association line, and the intervals are used to express multiplicity. Now what does it mean? For example, we have we'll just have an example of let us take an example, a car. This is a class, let us say, is driven by person. So we are having a relationship between car and person. Now next is how many objects of car can be related to how many objects of person. If you want to model that, that is modeled through multiplicity. So multiplicity shows how many number of objects are associated with how many number of objects with the other class, and that can be done through multiplicity. And this is some of the notations that are used for indicating multiplicity. Like I'll take up more into more detailed explanation about that, but before I go into that, I'll just take up the notations that are used for indicating multiplicity. Like for example, when you like 0 double dot hash, it's written something like this: 0 double dot not hash star. What does it mean? It means 0 or more objects are. It is related to 0 or more objects. Normally multiplicity is written here. It's something like here 0 or more. For example, so it's something written like this. 0 or 1, it means either 0 objects or no objects. The relationship is modeled through connected, or rather we can say the number of objects associated is either 0 object or 1 object. Here it is at least 1, that means 1 or more than 1. Here it is only 1, 3, between 3 to 5 objects. Here again these two are same, 1 and only 1 can be written this way or this way, and this term means 0 or more. This star is same as this one. So these are the notations that are used to indicate multiplicity. Again, multiplicity, what does it do? It models the number of objects that are associated with an instance of the association. So we have taken, this is an example, let us say this is an example of association along with multiplicity. Association, as I said, it can be either here we are why are we not saying link? We are not saying link because here we are taking class diagrams. So class diagrams really are modeled by the relation association. So we are talking about association and the multiplicity. Now what here, if you see, we have star at one end and 1 in the other end. That means one company can have many employees. That is the meaning of this multiplicity relationship. Or we can say in one company you can have many employees working. So 1 to, this is a case of many to one, we can say, right? But in one company, only one but in one employee, give me a moment, but in one employee, only one company can work. You cannot have one employee working in more than one companies. This is not, this particular multiplicity doesn't indicate this. This multiplicity indicates in one company you can have number of employees working, employee 1, employee 2, employee 3, and so on. Now let us come to the second one. Now in the second one we have manager related to administrative assistant, and the multiplicity is here the administrative assistant, when it is star. Star means it is 0 or more than 0. That means from 0 it can be anything, 0 onwards. 1 and star means from 1 onward. That means a manager can have either no assistant, one assistant, or any number of assistant when you are going from this direction to this direction. And if you are looking from seeing it from this direction, we can say an administrative assistant will either have one manager, two manager, or more than any number, or rather we can say any number of managers. Similarly, in this example, it's a 1-to-1 multiplicity. That means one company is taken care of by one board of director, or if you're going from this in this direction and you are looking in the reverse direction, we can say one board of director is therefore only one company. Similarly, similar explanations can be taken care of for the next example. Now, next point is, how do you label the association? Now, what we are doing is that we are right now talking about what we have talked about right now. We have talked about class diagrams. We have talked about class diagrams. We have talked that you have the class name, we have the attributes, we have the operations. This is what a class diagram is. Next, what we have talked about, we have talked about class diagram. Let us say this is your class diagram 1, this is your class diagram 2. Next, we are saying that two or more classes can be related to one another, which is modeled through association. And now what you are doing, this relation, we call it as association, and this relation we can give a name to this relation. Now each association, as I said, it can be labeled. Why do we label it? It's only to make it much more easier to understand, much more easier to read, or rather to enhance the readability. So we can label the association to make explicit the nature of the association. That means to make it explicitly clear what kind of association exists between the related class diagrams. In this class, we are saying employees and company are related, having multiplicity star. That means it is many in one end and one in the other end. So the multiplicity is many to one. And what is the relationship? What is the name of the relationship or name of the association? It is works for. So we can label the association by writing the name of the relationship just on top of the line which is showing the association. This is different. This is not association. This is where I'll come to this again in the next slide. Right now I'm not explaining. This is association, where just it is written in the middle between both the relationships on top of the line indicating the association. So we can say employee works for company. We can say office allocated to employee. And these are examples of labeling of association. This is different. I'll come to this in the next slide. Now let us look more into this, how to analyze and validate associations. Now we have, as I told in the previous example, we have, when you're talking about multiplicity, we have three kind of scenario. One is many to one, the other one is 1-to-1, and then we have many to many. These are the possible kind of multiplicity that can exist if we are seeing it from a generic point of view. Now, if you're taking an example of many to one relationship, you can say here a company can have, one company can have many employees when you're seeing it from this direction. And if you're looking in the opposite direction, an employee works for only one company. So we can say it is a case of many to one relationship. Fine. But if you look at this figure in more detail, we see that a company, this term means 0 or more. 0 or more. That means a company can have 0 employees also. What does this definition mean? We normally don't think of companies having 0 employees, but we have the special companies, shell companies, which you all know. So this is an example of 0 employees. This is an example of that particular scenario. And here it is a case of having many to one association. Fine. Now many to many association. So that means when you go from left to right, or when you go from right to left, you have this many to many association. Like for example, one secretary can work for many managers. One secretary can work for many managers. So that means one to many is existing. Now many managers. Now next is one manager can have many secretaries. One manager can have many secretaries. So we can, when you're going from the reverse direction, one manager can have many secretary. So a manager can have many secretaries, a secretary can work for more companies. And here another point is, a manager, since it's star, that means 0 to star, that means a manager can have 0 secretary as well. Now 1 to 1, that means for here each company can have only one board of director, one board of director can have only one company. Now this is an example of, more example of many to one. Many ATMs controlled by one bank, or one bank can have only one bank can have many ATMs, but many ATMs are coming under only one bank. Similarly, this example. Now this is now next is association and. Association, they have ANDs, they are called as association ANDs. For example, which I told you in the previous slide that I'll explain it later on. We have this class diagrams. This is your association. We have labeled the association, and this is the, we are naming the association at the end. We call it an association and they are called as role names. What are the roles that this association plays? Like who is a person? The role that a person plays, it is called, it is employee. The role that a company plays, it is employer. So association ends are role names, and we model it at the ends, or rather at the point near to the class. Like in the previous example, which I told that I'll explain later on. In this example, this manager, basically the role name is, manager can be a supervisor. Person, who is the person? The person is a board member. So these are the example of association ends or role names. Now association ends, association and names are necessary for association between two objects of the same class. So we normally take up, if we are having two objects of the same class. एक मिनट ये वाला स्लाइड ना थोड़ा डिलीट कर दीजिएगा. मैं इसको थोड़ा रिपीट कर सकती हूँ. मैं इसको कैसे क्या करूँ? अभी स्टार्ट कर रही हूँ. अच्छा okay. So association have ends. What do we mean by that? They association, by association ends, we basically refer to role names. It is normally written at the end of the class diagram, that is written adjacent to the class diagram. So like here we are saying employee. Basically employee is a role name of the person, of the class person. Employer is the role name of the class company, right? So we have this, these are role names or ends. These are the labels of the association. And if you look at this example here, these are the objects of the class person, Joe, Mary, Jean. These are objects of the class company, Simplex, United Widget, and so on. Association and names, these are optional. It is not mandatory. Association and names are normally necessary for association between two objects of the same class. When you have two objects of the same class, then it becomes mandatory. Like if you look at this example, we have a class directory and we have a class user, but we have got two different kinds of user. One is an owner and the other one is an authorized user, for example. So what we do is that when it comes to owner, we are having only one owner which is connected to multiple directories, and when it comes to authorized user, it is many to many. So in this kind of situation, we have this scenario where association and names becomes mandatory to be placed. Association and names also helps us unify multiple references to the same classes, something like this. This is, if you have through and names, this thing can be avoided. Here if you just see, instead of taking, though these two are belonging to the same class, but we have a different kind of relationship, but which if you model it like this, it doesn't give much of meaning. So here what we do, through this association and name, we can indicate two different things. Like you can have person, you can have child object of class person. Many child objects of class person can be related to 0, 1 or 2 objects parent of the class person. So in this kind of scenario, we need association and names. So association and names becomes necessary under this two scenario. These are examples of relationships. Like if you have a scenario like student working in, a student being instructed by one or more instructors, and we have a scenario like an instructor instructing one or more students, then both of them combined, we can have something like this, many to many relationship. When we have both the scenario being applicable, then we have scenario something like this. This is an example of multiplicity constraints. we have students registered for semester, we have students taking class sections, we have semesters. Now, next point is qualified association. What is a qualified association? It basically associates two objects using a qualifier to select objects at the other end of the association. It is basically used to associate the objects for a many association. Let me take an example, things will become more clear. Here, if you look at this example, we have without qualified association, we have a scenario like class bank linked to class account, and the association is one to many. That means one bank can have many number of accounts. Now, this is not qualified. Now, if we can reduce this one-to-many relationship to one-to-one relationship if we add a qualifier. Now, what is a qualifier? It is basically an association through which we can do the reduction. It is basically, what qualifier is an attribute or a set of attribute which has a unique value for each object in the class. Here, if you look at it, bank, though one bank can have multiple accounts, but one bank have an attribute account number, and if you look at the account number point of view, one account number corresponds to only one account. So, this thing can be further broken up by using a qualified association, and we can come down to a relationship of we can break it from one-to-many relationship to one-to-one relationship. So, qualified association helps us from going to one-to-many relationship to one-to-one relationship. So, this is the reference slides which are the books which I referred. That much for now. Thank you.